Okay, I'm doing this with the document camera, and I may split this into two pieces. It depends how long this is going to take. Okay, first problem. A vehicle is at rest at time equals 0. It accelerates at a non-constant acceleration for 5 seconds. There's an A in there that doesn't belong. The resulting equation for the distance traveled in the first 5 seconds is S of t equals t over 9. Is n in t is in seconds, S of t is in meters. What is the vehicle's acceleration at t equal 3? So acceleration is the second derivative. Velocity is derivative. Now, so there's the function. 9 is a constant. It could also be 1/9 t. The reason I say this is a lot of people use the rule for some reason. You don't need the quotient rule here. S prime of t is going to equal 1/9 times 3t squared. And then S double prime of t is 1/9 times 3 times 2t. So that's the same as 2/3 t. S double prime at t equal to 3 is equal to 3 times 3, which is 2. And the distance is in meters, right? And velocity is meters per second. Acceleration is meters per second. And so you put meters per second squared, or m over s squared. Okay? Second one. Inverse function theorem. What is the slope of the tangent line inverse of x at x equal 1, given that f of x is this function and 3 equal 1? If f of 3 equal 1, that means that f inverse 1 equals 3. Okay? Now, take of x, take its derivative. Its derivative is what? Minus 6x plus, plug in f of 3, because we want the slope at f, and figure out the slope of f inverse at 1. Got that? So f prime of 3 equals minus 6 times 3 plus 1, which is mean. Flip that over to get f inverse at 1. So f inverse at 1, f inverse, boy, I hate this notation, prime at 1 is equal to 1 over minus 1, minus 17. Okay, got all that? And I didn't write off the page. Okay, next one. All right, so about assessing whether both you remember the inverse trig derivatives, which you should have on your little sheet, and mostly the chain rule. Okay, so we're going to do the chain rule. So we have a function, f is a function of u. Its derivative with respect to x is the derivative of f with respect to u times the derivative of u with respect to x. Okay, I'm going to use that notation here. Okay, I'll put that way at the top. Okay, derivative of f with respect to x is the derivative of f with respect to u times the derivative of u with respect to x. Okay, so f of x here is arc tan u, where u is x squared plus 1. Okay? So df dx is the derivative of arctan, so that's 101 plus u squared, right? Derivative of f with respect to u times the derivative of u with respect to x. The derivative of u with respect to x is 2x. So let's substitute for u. We get 1 over 1 plus x squared times 2x. Do not simplify. This is not an algebra class, it's a calculus class, and if you simplify, you're going to make mistakes. So don't do it. Do not simplify. Okay, next one. Here, x is equal to u squared, where u is equal to arc sine x. Okay? So df dx is equal to df du, 2u, times the derivative of u, 1 over the square root of 1 minus x squared. Substituting u back in, we get twice arc sine x times 1 over the square root of 1 minus x squared. Okay? Here, f of x is log u, where u is x squared 3x. So df du is 1 over u. Du dx is 2x plus 3. Don't forget it. Substitute for u, you get 1 over x squared plus 3x times 2x 3. And I would just leave it like that. Put the 2x plus 3 on top, but I wouldn't even bother to do that. I just put a bracket there. Okay, the last one, this is a problem. This is a quotient rule problem. Okay, f prime of x, using the quotient rule, bottom sine of times the derivative of the top, e to the x, minus e to the x times the derivative of the bottom, cosine of x, all over square. You can put the 2 there, or you can put it over. Whoops. I missed that, sorry. The bottom times the derivative of the x is e to the x, minus the top times the derivative, all over the bottom squared. I put the squared right there. You could have put brackets and put squared if you wanted. Okay. Next. Scroll down so you can. All right. Let's take the dy dx in terms of x and y by doing the derivative implicitly. Now think of y as a function now of x. We just don't know what it is. If I differentiate across the board, I get 2y prime. I could put dx, but it's easier. Okay, 3, the derivative of 3y is 3 times the derivative of y. So that's 3y prime minus 2, its derivative is 0. So that equals derivative of x squared is 2x. Derivative of minus 3x is minus 3. Factor out the y prime here on the left. And then divide by y plus 3 on both sides, so y prime is equal to 2x minus 3 over 2y plus 3. And just leave it like that. That's what I asked for. Okay, next one. Find the second derivative. Okay, so we have to do what we did before, but do it twice. Okay, I'm going to put that on the next video.